All right, so what we're going to be doing today is we're going to go through 9 questions. That's right, folks, 9 questions on this rational equations and functions unit test. And so what we're going to do is carefully write this equation down. So I'm going to do it in blue because I like blue. 2x squared minus 4xy all over 3x plus 6y. That's a division symbol, okay? That's a division symbol. So it says divided by, we've got an xy plus a y squared all over x squared plus 3xy plus 2y squared. Now that's a bad boy right there. What we're going to do is you're going to carefully write it down, and then we're going to show you guys what to do to simplify this rational expression. We're going to just simplify it. We're going to make it simpler. All right, so what we're going to do is I'm going to highlight this very first one. Okay? You're going to highlight. And what I'm going to do is I'm going to factor out the greatest common factor out of this. So what's the greatest number that can go into a 2 and a 4? 2. So I'm going to put a 2. Do you guys see how it has an x that's common to both? The variable x that's common to both. So we're going to factor out an x. Okay? Now, inside of this, we're going to be left with an x minus a 2y. And that's what we're going to be left with right up here in the numerator. Okay? All right. Now we're done with the numerator. Just leave it. Just leave it. Just leave it. Just leave it. There we go. Now I'm going to highlight the denominator, which is right here. There's the denominator. Now, what's the greatest number that can go into a 3 and a 6? 3. That's right. And then this right here, it looks like this is just going to be an x and plus 2y. Now, these don't cancel out because they're not the same. Okay, so don't get too trigger happy now. Okay. So ever see the division symbol here? When you divide a fraction, you get to multiply it by its reciprocal. So we're going to change that division sign to a multiplication symbol. Okay? And what we're going to do right now is we're actually going to factor, we're going to factor this guy, and when we factor him, we're going to put him right up here on top. Okay? Do anybody know any numbers that add together to equal 3, but they multiply together to equal 2? You're right. So we're going to put x plus 1y and x plus 2y. We're going to put them right here, up here in the numerator. Now, why are we putting them in the numerator? Here's the rule. If you have a divided by b divided by c divided by d, that's the same as saying a divided by b times d over c. Okay? So when you're dividing fractions, you're actually multiplying by the reciprocal. See how the d goes on top and the c goes on the bottom? Probably when you're in elementary school, you probably had an elementary school teacher that said, keep it, change it, flip it. This is the keep it, this is the change it, and this is the flip it. Yeah, so you keep this the same, you change this from a division sign to a multiplication sign, and then you flip it. That's the whole keep it, change it, flip it. Probably haven't heard that in a while, all right? Just like you haven't heard of recess in a while. Now, I know, I miss recess too. That would be the only thing that would draw me back to teaching like elementary school kids is getting to have recess with them. Well, I have one student, she misses nap time. Okay, so guys, right here, I don't know if you guys, do you guys see how there's a y that's common to both right here? So we're going to factor out a y, and we're going to be left with x plus y. So all I did was factor out a y out of the numerator. And I'm going to put the y down here. I'm going to put x plus y right here. Now, we're not going to multiply everything together, okay? We're not multiplying everything together. Now we have everything, keyword, guys. This is what we're really, this is the whole purpose of this is make sure you guys know how to factor. Everything is now factored. Once you have everything factored, now you can cancel out factors that are equivalent to each other. So let's just scan here. X plus y, how about we'll use orange. X plus y can cancel out this x plus y. Does everybody see x plus 2y right here? that can cancel out this x plus 2y. So those cancel out. So let's think about this. What do we have left now in the numerator? A 2x and an x minus 2y all over, what's the only thing I have left remaining in the denominator? A 3y. Now, if they want it in expanded form, we would have to distribute and get 2x squared minus 4xy, because 2x times x is 2x squared, and 2x times a negative 2y is a negative 4xy all over 3y. Okay, now this is, I'm going to look to see if they say expanded, okay? So it doesn't say expanded. So we should be able to type this in, and it should still work. Okay. So let's just make sure we got everything factored correctly. This right. I'm just going to check real quick. I'm going to pause the video. All right. So we're going to go ahead and type this in. All right. All right. So we have. I'm going to go and try. I'm going to type it in factor form and see if they accept it. All right. 2x parentheses x minus 2y all over 3y. All right. Help me out, y'all. Put a little division bar. What was the numerator? 2x parentheses what? X minus 2y all over a 3y. Nailed it. Now I'm gonna see step by step, okay? And see, they probably had an expanded form. There, see, remember there's the expanded. So this right here is factored. There is expanded. So they would have accepted either way. All right. Next problem. Okay. I'm gonna write it a little bit bigger so you guys can see. Here we go. 3 minus 10. Whoa. That's supposed to be a z. There we go. Over 10z squared minus 3. Okay, there's a minus sign, so put a little minus sign over 12z plus 5 over 10z squared minus 3. All right, and all we're going to do is we're going to subtract the following rational expression. Now, what do you have to do in order to add or subtract fractions? What do you have to have the same? You guys remember that from elementary school? When you're adding or subtracting fractions, you have to have the same denominator. Well, we lucked out. We have the same denominator. All right, so check this out. We can actually take this and we can take away this right here. We can take those away. So that's all we're going to do. So all I want you to do on your paper is do 3 minus 10z. I want you to put a minus sign, open up a parentheses, and write 12z plus 5. It's going to be important that you put the parentheses because we have to take away both those numbers. Okay? We don't just take away the first one, we got to take away both of them. So we have 3 minus 10z minus 12z minus a 5. So this stays the same. What do we have to do? That makes it a negative 12z, and that makes it a minus 5. So let's combine our like terms. How many z's do we have total? Negative 22 z's. And then we have a 3 minus a 5. And what's 3 minus 5? Negative 2. Okay? All right. Now, this is what's going to go up there in the numerator. So we're going to have negative 22z minus 2 all over the same denominator, 10z squared minus 3. Now, I don't think we're going to be able to factor anything out of this. 3 and 10, there's no common factors. We could factor out a 2, but that's not going to really cancel anything out. So I'm just going to type this as our answer and see if that's simplified. Okay. So all we do is we had a common denominator, so we were able to to type it in. So negative 22z minus 2 all over 10z squared minus 3. There we go. Let's see if it works. Negative 22z. Whoa, negative. Sorry, that would be bad. Yeah, that would have been bad. Negative 22z minus 2. Is that what we got right there? All over 10z. I got to make the little squared thing right here. Squared minus 3. All right, let's see. Hey, 2 in a row. Sweet. Oh my goodness gracious. Okay, so all you guys, this is going to be an easy one. All you guys need to write down is just the f of x, okay? So just f of x equals 3x squared minus 3x minus 60 all over h of x. That's really all you need to write down on this one. This reveals everything, okay? So let me talk to you about the first thing it's going to reveal. First thing we look for is zeros. The second thing we look for is what's called removable discontinuity. And the last thing we would actually search for, if we don't find any zeros and we don't find any holes, also known as removable discontinuity, then we look for vertical asymptotes last. So we don't look for the asymptotes first in the numerator, we look for them last, okay? So we got to factor this guy. So we're going to take out a 3. We're going to factor out a 3. And that leaves you x squared minus x minus 20. And when we factor it, we get x minus 5 and x plus 4 all over this thing, this function called h of x. So I'm going to go ahead and kind of go like, how did I factor it? 3 goes into all these numbers, so that's why I factored out a 3. And then if you're wondering how the world did I factor this to this, I was looking for 2 numbers that added together to equal a -1, and those same 2 numbers multiply together to equal -20. And those 2 numbers are a -5 and a 4. That's how I got x minus 5 and x plus 4. Okay. So what are some numbers I could plug in here to make the numerator equal to 0? So what am I looking for? X equals a positive 5 and a -4. So I'm looking for graphs. Okay. All right. So right now, first thing, what are we going to look for? Before anything else, we're going to look for zeros. What's the 0 right there? 5. What's the 0 right there? -4. So that's why I'm going to choose A. Okay. Now, if this was in the denominator, if this expression was in the denominator, we would look for asymptotes first. But when it's in the numerator, we look for zeros first. Okay, so we're going to choose answer choice A because it has zeros at 5 and -4. All right. Okay. Now, this one, what we're going to do is we are going to actually describe the behavior of the function around its vertical asymptote at x equals 1. So what I'd like you to do is I'd like you to write this down. I'd like you to write this down. And then we're going to type it into Desmos together, and we'll explain what the answer is after you write it down. Okay? All right, so we go over here to go to Desmos. Okay, let's go ahead and type it in. And I'm going to type it in as exactly as it appears. H of x equals, put a little division bar. What's up in the numerator? X squared plus 4x minus 21 all over x minus 1. Okay, so I'm going to type in the vertical asymptote, x equals 1, which is right there. Okay, we're going to zoom out. Okay, and we're gonna draw a little sketch. You guys are gonna draw a little sketch of this. Okay, you're like, a sketch of what? Sketch of this. So what I want you to do, how do you draw a sketch? The first thing you do is you just draw a little asymptote. Okay, just draw a little asymptote. Okay, and then if we look back at this, can you guys see how the red, as it's going towards that, right? As it's going towards the asymptote, what's happening? It's going up from the left-hand side. All right. And as it's coming towards the asymptote from the right-hand side, what do you notice? From the right-hand side, what's happening? It's going what? It's going down. So this guy looks like it's going up to see Jesus. This one's going down to see Satan. All right, so this is from the right-hand side, okay? So as x approaches 1 from the left-hand side, by the way, sometimes you'll see a minus sign, and that little minus sign means from the left. What is, I guess ours is h of x, sorry. What does h of x approach? As it's approaching from the left, it's going what direction? Positive infinity, okay? And as x is approaching 1 from the right, so I'm kind of giving you guys two sets of notes because you guys might get a question where you have the minus and the plus instead of just words, okay? What is h of x approaching? Negative infinity. And that's the answer that I'm going to be looking for, okay? From the left, it's going to positive. So the graph of h approaches, nope, positive infinity from the left and negative infinity from the right of the asymptote. Okay, so I'm going to say answer choice C best represents what's happening in this graph. Okay, and I try to put the minus and the plus because they might actually not have words. It might just have these symbols, and I want to make sure you understand what the symbols mean. Okay, so I'm going to choose C, but not on this page. On this page, it approaches positive infinity from the left and negative infinity from the right. Okay, here we go. I'm going to write it right here. F of x equals negative 2x squared plus 3x minus 7 all over negative 6x squared plus 9. So go ahead and just carefully write this down, and we'll talk about the end behavior. This is going to be really, really easy. Okay, super easy. Pausing it. Make sure you write that down. Uh-oh. My daughter reminded me we have a physics project to do. By the way, if you don't like homework, don't have kids. So if you're like, man, I can't stand homework, don't have kids. Just, you know. Okay, everybody got this written down? We good? Okay. All right, so one of these, there's 3 rules that we have to be aware of, okay? So you guys should already have this in your journal, okay? But in case you don't, if you have a times x to the power of m plus I don't care over b times x to the power of n plus I don't care, if the m value is equal to the n value, that's the scenario we got going on right here. This power is equal to this power. Then that lets you know your end behavior is just y equals a over b. And what is our a value? Negative 2. What is our b value? Negative 6. All right? The walrus just needs to stop talking right now. Okay? And that reduces to 1/3. So without having to do a whole bunch of work, I know the end behavior to the right and to the left as this is going to infinity to the right and infinity to the left is going to get really, really, really close to 1/3. Now, what are the other 2 rules? This is rule number 1. If m is equal to n, it's y equals a over b. Rule number 2. If m is greater than n, then there are no horizontal asymptotes. So put, well, none at all. When I say none, I mean there's none horizontal, not going to be any. Step 3, number 3, if m is less than n, then your horizontal asymptote will be y equals 0. So if the power in the numerator is less than the power in the denominator, all right, if this is less than that, then it's going to be y equals 0. If it's greater, there's not going to be, and then we have to use the little chart we talked about, okay? And if you're like, what's the chart? Well, you have to look at a previous video that I did dealing with the chart that you guys see on my board, okay? So right now, what are we going to choose? 1/3 and 1/3. Oh my gosh, it's like they already knew I was going to need 1/3. Crazy. Okay, all we got to do, guys, right here, is write this down. We've got x squared plus 4x minus 32 all over x squared minus 8x plus 16. And we're going to really focus in on factoring, once again, the numerator, and factoring the denominator. Okay, so let's take a look at this. Write that down, and we're going to factor it together. All right, so right here, we're going to factor the numerator. So what is the numerator factor? I know some of you probably have already done it. Say it again. X plus 8, x minus 4. There you go. And let's take a look at the denominator. That's going to be x minus 4 and. Okay, so this is where we have to make some decisions here. Okay? I know. Right. So we got to make a decision. Check this out. Would you guys agree the number I could plug in here to make it equal to 0 is 4? And the number I could plug in here to make it equal to 0 is also 4? But these cancel out. And when something cancels out, what do we call that? Removable discontinuity. Where? At x equals. But we also have what? A vertical asymptote at x equals 4. So you have to ask yourself, what's more powerful? One little hole or an asymptote full of holes? An asymptote full of holes is more powerful than one little tiny hole. So therefore, we're going to choose a vertical asymptote at x equals 4 versus one little tiny removable discontinuity. It's like, do you want to deal with one little zombie or a horde of zombies? Neither. But the horde of zombies is more powerful than one little zombie that has a hole in their head. Okay? Now, a 0. So right up here, guys, at -8, what do we have? We have a 0 at -8. Remember, in the numerator, what do we have? Zeros. In the denominator, what do we have? Or vertical asymptotes. Number one, we have vertical asymptotes. And I realize, yes, if the only way to kill a zombie is to take their head off and shoot their brains, whatever. So please, all right. But all I'm saying is, just vertical asymptote at 4, 0 at -8. So vertical asymptote at 4, 0 at -8. Okay, here we go. Eventually, I'm going to write it down nice and neat. I'm just going to keep trying. All right, if everybody would please, all we're going to do is we're going to factor this guy, and we're going to be careful. We got to make sure we're in expanded form. So be wary, be diligent to know when it has to be in expanded form. Okay? Yeah, we're almost done. So I'm going to highlight that guy. Going to highlight this guy. Whenever you guys are factoring, you have to first look for the numbers that you could possibly factor out. So like, what number could you factor out of the numerator? An 11. So when you factor out an 11, you're left with x squared minus m squared. Okay? And what number could you factor out of the denominator? 2. So we're going to factor out a 2. And we're left with x squared plus 2xm plus m squared. There we go. Okay. Now, guys, this is where I would love if everybody understood what this is versus what this is, okay? So I'm going to put some labels on it, okay? Like actual vocabulary. This is referred to as a difference of squares. That's a difference of squares, okay? That's why this is going to factor to simply an x plus an m and an x minus an m. That's a difference of squares. This is one of the most commonly tested things on any math test that I've ever taken is they have difference of squares hidden inside of problems, okay? Either students recognize them or they don't recognize them, okay? This is not a difference of squares. This is what's referred to as a perfect square trinomial. So we put a 2, and this is going to be x plus m times x plus m. Why? Because what two numbers add up to 2 but multiply together to equal a 1? A 1 and a 1, like a 1m and a 1m. If we were to do, some people like the box method, okay? So we're just gonna, all right? All right. So let me make sure you understand what I see by the little box method. Oh, that was not a very good. I'm not muted. No. Okay. So right here, if I put an x and an m and an x and an m, x times x is x squared. Here I've got an x and an m, and I got another x and an m. Here I have an m squared. How many xm's do I have? A total of 2. So when you add them all together, you get x squared plus 2x m plus m squared. Well, what if you wanted to put it in alphabetical order? That's okay too. These all mean the same. They all mean the same thing. Okay, because they're all being what? Just added together. But right now, let's take a look at this. What can I cancel out? The x plus m and the other x plus m. So what do I have left? I have an 11 times an x minus m, and I have a 2 times an x plus m. But this is where I got to be careful. I got to make sure I expand it because they want it in expanded form. So I got to make sure I put 11x minus 11m over 2x plus 2m. And this is the answer I'm going to type in because I have typed in these answers before where it is the right answer. It just wasn't expanded. So I'm going to give you a chance to write that down. I'm going to type it. I'm going to type it in. All right, 11x minus 11m over 2x plus 2m. All right, there's the fraction. 11x minus 11m over what? 2x plus 2m, like that. All right, here we go. 2 more to go and we done. 5x. Oh, the last answer was 11x minus 11m over 2x plus 2m. Okay. All right, so right now, here's what we have. We're adding 2 fractions. Unfortunately, these 2 fractions do not have the same denominator. Okay? So that they don't have the, so right now, what I want us to do is I want us to factor this. That makes this an x plus 2 and an x plus 2. We're going to factor this guy. We're going to factor out a 3 and an x, and that's going to leave us with an x plus 2. So I'm going to highlight and focus in on our denominators. Here's 1. Okay? Here's the other. Okay. What we actually have to find is this concept called the least common multiple between this guy and this guy. Do they share anything in common? You guys see anything they share in? So guess what? We know we have an x plus 2. Okay. They both have one of them. Okay. But this guy has two of them, right? So we actually have to use, but they got to have both of them. They can't just have one of them. They have to have both of them. So this right here. Now, what else does this guy have that this guy does not have? 3x. So guys, the least common multiple between these two denominators is an x plus 2, an x plus 2, and a 3x. That's what our denominator is going to be. Okay? So right now, let's take a look. Let's rewrite everything. It won't take long to rewrite it. This will probably be the last problem that we do today. Okay? And hopefully what I'm about to do, this will make a lot of sense as we add these two expressions together. Okay? So I'm going to change some colors up here. What does this guy need that it does not have in the denominator? A 3x. So here's what I want you to do. I want you guys to multiply this by a 3x and a 3x. Okay. What does this need that it does not have? Another x plus 2. Very good. Does everybody see now, if we just focus in on the denominator, does everybody see we have all these, now these denominators perfectly what? They perfectly match. So what do we have to do with these 3x and this x plus 2? I have to distribute it to the numerator. This is going to be the easy part. Ready? What is 3x times 5x? 15x squared. What is 13 times an x? 13x. What is 13 times a 2? 26. Okay, so here's what we got. We have 15x squared plus 13x plus 26 all over a 3x and x plus 2 and another x plus 2. There's my denominator totally factored out. This is if I added the 15x squared to the 13x to the 26, and I can put everything together in the numerator. So that is what I'm going to type in as my answer. Okay? Because I don't think I can actually factor anything out that's going to make a difference, but I am going to try. Okay? So if I put the only thing that could possibly cancel out would be an x plus 2, and I have to put a 13 here, but that would be a 30. That would make it too much. So I don't think it's going to factor to an x plus 2. So I'm just going to type it in. If I get it wrong, it's okay. It happens. All right. So right now I'm going to type it in. What was in our numerator? 15x squared. All right. 15x squared plus 13x plus 26. Wow, we had a 3x, then we had another x plus 2 and another x plus 2. Wow, look at there. So see step by step. See all those right there? You can look through it, see step by step. I'll be continuing this video into my next period. All right, here we go. Our very final question. It says 2z plus 7 over 2z plus 10 plus 9 over 2z. z to the power of 5. So once again, when you are adding rational expressions that do not have the same denominator, you have to find what's called the common denominator. We're going to find what's called the least common multiple between these two. All right, the first thing we're going to do is we're actually going to factor out the number 2. When we factor out the number 2, we have a z plus a 5. And here, if I broke this down, I have basically a 2 times z to the power of 5. So does anybody see anything that these denominators have in common that would be a part of our least common multiple? Anything they have in common? 2. So the least common multiple, you're going to have a 2. What do you know has to be there? A z plus 5. What else has to be there? Z to the power of 5. So our least common multiple is going to be a 2, a z to the power of 5, open parentheses, and a z plus 5. This right here is called the least common multiple, and it's going to be what's known as our denominator for both expressions. We got to make this our denominator. Okay? So I'm going to rewrite everything factored here in blue. I've got a 2, I've got a z plus a 7, and I've got a 2 parentheses z plus 5. Here I have a 9 over 2z to the power of 5. So let's look at this one. What does this denominator not have that it needs? What does this guy not have that it needs from this? Anybody see? Yeah, z to the power of 5. It needs it. So what we're going to do is we're going to put a parentheses right here. And we're going to multiply this by z to the power of 5 and z to the power of 5. Because this denominator needs the z to the power of 5. What does this denominator need that it does not have? Like, what does this denominator now have that this one actually needs for them to match? Like if you're playing the matching game. Not just the plus 5, but the z plus 5. So all we're going to do is we're going to put z plus 5 over z plus 5. Now when I do this, now these denominators all match. So here we go. What's our denominator? Our denominator is 2z to the power of 5 times z to the power, z plus 5 right there. So what do I do with this? I have to distribute it to both terms. So if I distribute that to both terms, what am I left with in the numerator? What is 2z times a z to the power of 5? That'd be a 2z to the power of what? Remember, that's a 1. Z to the power of 6. And what's 7 times z to the power of 5? That's just what? 7z to the power of 5. And we're done with that part. Plus, what do you think I'm going to do with this 9 right here? Just take that 9 and do what with it? Distribute it. So what is 9 times z? 9z. 9 times 5. 45. Now, it's probably been a while since you've added fractions together. But the only way you can add fractions together is if they have the same denominator. That's why we did all this work, because I needed us to have this denominator right here match this denominator right there. So I wanted those to match. So once they match, then we can add everything in the numerator. What are we going to add together in the numerator? We're going to take all of this, and what are we going to add to it? That right there. Would you guys agree there's no like terms? There's nothing we can combine. So here's our final answer. 2z to the power of 6 plus 7z to the power of 5 plus 9z plus 45 all over 2z to the power of 5 parentheses. No, z plus 5. Guys, this is my final answer, adding them all together. Now I'm going to carefully type this in. Okay? Going to carefully type this in. And if I made a mistake, we'll find out. If I made a mistake, then we'll figure out where that mistake was. All right, so I'm going to go over here. Hopefully you have it written down because I got to type it in nice and neat. Probably go back and forth. Here we go. Right there. So I'm putting a little fraction right there. What was in the denominator? What was our common denominator? Real quick. It was 2z to the power of 5. 2z to the power of 5. Z plus 5. So there's our denominator. And then, holy moly, we got a long one. We got 2z. Let me type it in now. We got 2z to the power of 6 plus 7z to the power of 5 plus 9z. Wow, that was a lot of work. Sure hope it's right. Oh my gosh, it's right. It's like we just trusted the process. Holy cow. Okay. So, right now, I'm going to do a few more problems right here. No, not. All right, here we go. If you would please. We're going to go over some more problems right now. I've already done one whole unit test. Now I'm going to start another one. Once I get to a certain point, I'm going to stop the video, okay? Because, it just gets dull. Probably already put a few people to sleep already, and they're already in class. All right, so we have q of x over x squared minus 5x minus 24. So if you would please write that down carefully in your journal. We'll show you guys what to do when you need to identify this graph. Whenever you have something in the denominator, here's the first step. Step number 1, you're going to look for what's called vertical asymptotes. Okay? Got to look for vertical asymptotes. Step 2, we're going to look for this thing called removable discontinuity, also known as a hole in the graph. Okay, so whenever you're dealing with the bottom, what are you dealing with? You're dealing with asymptotes and holes when you're dealing with the bottom in the denominator. But bunch. Sorry, math joke. So we got to factor this baby. We're looking for two numbers that add up to what? -5. And those same two numbers multiply together to equal what? -24. Okay? Man, what are those numbers? -8 and 3 and -8 and 3. So we're going to put x minus 8 and x plus 3 because they multiply together to equal that. So what are we looking for? We're looking for where x is equal to what? And 8, and where x is equal to a -3. What are we going to be scanning all the graphs for? Vertical asymptotes and holes, or removable discontinuity. I'll put holes so you know what I'm talking about. They're like little tiny holes that can't be graphed. Okay? So right now, where is this asymptote? Right there. Yeah, I'm not going to choose that. What about there? -5. Okay. How about there? 8. Ooh, how about there? I'm feeling pretty good about B right now. That's probably the answer. Okay, let me scroll down. That's a 6. Nope. Nope. That's a 2, right? So what are we looking for? Right there. 8 and negative 3. There's an asymptote. There's an asymptote. Choosing B. Okay. All right, guys. Next one. Here we go. This one you're going to have to take some time and energy and write it down. 6k squared minus 36k over a times k squared plus 12k plus 36 over k squared minus 36 all equals a 1. And the question says, what is a? Oh my gosh, it looks so complicated, but it's really not. Just write it down. What we're going to do right now is we're going to factor. We're going to factor this guy. Okay? We're going to factor this guy. And we're going to factor this guy. So let's go ahead and get this stuff factored right now. Okay? What I'd like you guys to do is we're going to factor out a 6 and a k out of this expression right here. And you're left with a k minus a 6. Does anybody know two numbers that add up to 12, but they multiply together to equal 36? All right, 6 plus 6 and 6 times 6. We put k plus 6 and k plus 6. Guys, this is called a perfect square trinomial. Okay, that's what it's called, a perfect square trinomial. What does this guy factor to? K plus a 6 and a k minus a 6. What is this guy called? Difference. It's just a difference of squares. Okay, that's called the difference of squares. Okay, now we're almost done. Literally, we got to make all of this equal to a 1. Now, here's the concept you need to understand about this. What is 5 divided by 5? 1. What is 4 divided by 4? 1. Well, what if I said this? Ready? What if I made this a little 4th grade problem? Here we go. 5 divided by empty box equals 1. What number would you have to put in the empty box? 5 in order to make it true. So how are we going to use this concept for our problem? Right now, let's look at the numerator. It's got a what? A 6k. It's got a k minus 6. And it's got a k plus 6 and another k plus 6. So let's just write down everything that we have in the numerator. Okay? So right now, we have a 6k. All right? We have a k minus 6. We have a k plus 6, and we have another k plus 6. All over, we have a k, not an x, sorry. We have a k plus 6, and we have a k minus 6. And what are we looking for? We are looking for what would have to go here in order for it to all equal what number? 1. So if you would please just write that down and we'll show you guys like how would you figure out what would have to go there. So we get to cancel some things out so we see what's left standing. Would you guys agree this k plus 6 cancels out this k plus 6? And this k minus 6 cancels out this k minus 6. What's the only thing I have left? 6k and a. So what does a have to be? 6k and a k plus 6. If I had both of those down there, then everything would cancel out to a 1. And that's what a is equal to. Now, a is not equal to 1. A would have to equal 6k times k plus 6 so that we could do this. And everything would be canceled to a 1. So we have to get Now, I don't think it says expanded form, okay? So right now, that's what I'm going to type in unless it says it needs to be expanded. No, it just says as a polynomial expression. So I'm going to type in 6k parentheses k plus 6. 6k parentheses k plus 6. So 6k parentheses k plus 6. All right. All right, here we go. Write this one down. I wish they'd stop with the z's. It's like, come on, people. Z's are not easy to write. Just leave it x's. Seriously. There we go. So this is what you guys are writing down in your journal. You also want to make sure that you, whenever we're done with this, it better be an expanded form. If it's not an expanded form, that would be bad. All right, so we're going to break this down and factor the numerator. And we're going to factor the denominator right there. So here we go. Numerator. What can we factor out? We can factor out a 3. How many z's can we factor out? Total of 5. And what does that leave us with? Z to the power of 6 plus 1. Just if you want to check your work, what do? You always do what? You always distribute to see if it gets you back to your original expression, and that does. Okay? Now this bottom one is actually a lot easier. Does anybody know two numbers that add up together to equal 4, but those exact same two numbers multiply together to equal a 3? That's right, 3 and 1 and 3 and 1. So this factors to z to the power of 6 plus 3 and z to the power of 6 plus 1. That's how it factors. Okay, so if you see a 12, what's that 12 going to split down to? A 6 and a 6. Okay. Anything, is there any number I could plug in there when added to a 3 that could somehow make it equal to 0? If anybody finds that number, please, I would love to know that. Now, in fact, I'll give you guys $100 if you can find the number that works. Or shoot, I'll give you $1,000. No, I'll give you all of my savings if you can find a number that gets. There's nothing. There's nothing that works. No, no, I'm sorry. 0 to the power of 6 is 0. 0 plus 3 is still 3. Because if you have an even power, what happens when you have an even power with negatives? They cancel out. So the smallest number you could plug in there would be a 0. All right, you cannot make that somehow equal to a negative once. Put nothing and nothing. Anything slash out? Yeah, so if you did 0 to the power of 6, still 0. And so 0 plus 1 is still a 1, so it doesn't cancel out. So what do I have left? I have 3z to the power of 5 over z to the power of 6 plus 3. So that's what I'm going to type in for my simplified expression. And what am I going to type in over here? None of the above. I'll go back right there. 3z to the power of 5 over z to the power of 6 plus 3. So I'll put none, make a little fraction, put 3z to the power of 5 over, what was it again? Z to the power of 6 plus 3. All right, so z to the power of 6 plus 3. I think I got, did I type it in right? Z to the power of 6 plus 3? I hope so. Good thing I did. All right, last problem we're doing on the video, and I'm going to shut it down because this is getting close to an hour, and whoever's watching this is really just depressed. Okay, so we have x plus 3 over x squared plus 2x minus 3. Okay. Now, guys, this is something you've seen before. Notice, this is something that you've seen before. Actually, the last problem, you've seen that problem too. Okay. What two numbers add up to 2 but multiply together to equal -3? X plus 3 and an x minus 1. Why? Because 3 minus 1 is 2, and 3 times -1 is 3. So let's write everything nice and factored. We got an x plus 3 over another x plus 3 and an x minus 1. So guys, what number makes that equal to 0? -3. What number makes this equal to 0? +1. But what happens? What gets canceled out? This x plus 3 cancels out that x plus 3. When that happens, what do we call that when factors get canceled out? So put RD, short for removable discontinuity, at x equals -3. What's the thing that happens in the bottom of the rational function? Vertical asymptote. So we've got a vertical asymptote at x equals 1. So those are two answers. Removable discontinuity at a -3 and a vertical asymptote at a +1. Okay? What do we have? Where was the removable discontinuity? -3. Where was the vertical asymptote? 1. Okay? So you have to know what is what. All right? Does this look complicated to you guys or not complicated? Yes. Very good. I had a student that says no because he recognized one thing and one thing only. They have the same what? Oh, thank God. They have the same denominator. When they have the same denominator, that makes everything nice and easy. Okay? So if these are the same, then we don't have to do all that work of finding the least common multiple and trying to find the same denominator because they're already the same. So what could I add together? The 6 minus the 8. What is 6 minus 8? -2. So here's what we're left with. -3x minus 2 over 2x squared minus, and that's your answer. So you're going to get 1. Now, guys, I'm letting you know, this was easy because it had a what? It had a plus. The other one that we had, way, way far ago, oh, right there, this one didn't have a plus, it had a minus, and I had to take that negative sign and what? Distribute it to both terms. That was from another period. They had a more difficult one. You guys actually got an easier one. Whoa, too far. Because it said a plus. That's what I'm going to type in as my answer. Okay? Oh, I better hurry before it hits the hour. Then I'll probably turn back into a pumpkin. All right, -3x. Oh, here we go. So here we go. What's going to be our denominator? Our denominator was what? 2x squared. Okay. And what was in our numerator? All right. There we go. I'm going to go and stop the video for now, but hopefully you get the gist.